Hey, good morning, guys. We'll be getting started here in just a second. Just waiting for there's Sebastian. All right, I think we have everyone set up as speakers and should be ready to go here. All right. Good morning. Welcome to our space with Sebastian from Kiln Finance. We have Kent, Muriel, and Harpreet. I'll let everyone go around and introduce ourselves. Kent, do you want to start and then just pass it around to
Yep,
everyone else?
happy to. Hello, everyone. Thanks for coming to our space again. My name is Kent, co-founder, COO at Optimum. Um, Very excited to speak to you guys about how we're unlocking Ethereum's scaling potential together with our partner from Kiln. Miri, you want to go next?
Yes, thank you very much, Kent. My name is Muriel Medard, Muriel Medard. I'm a co-founder and a CEO of Optimum, and we've been really excited to be working with Kiln in really scaling up using technology coming out of my lab at MIT with real emphasis on helping validators achieve the best APYs they can. And with that, I'll hand it to Harpreet.
Hi everyone, I'm Harpreet. I work on the engineering side of the Optimum team on the protocol level. And yeah, for the last few months, one of our goal has been to make consensus layer message faster, propagate data faster, and that's something which I'm doing here.
I can be next. I'm not sure if my mic is working.
Yes.
So I'm,
It is.
Okay, so I'm Sebastian. I'm working at Kiln on research and development. I'm mostly focusing on Ethereum. So we are operating about 5% of the network. So that's 55,000 validators. And yeah, we are interested in Optimum as we think it can help the network by improving propagation, well, the propagation of blocks and attestations. And I guess this is what we're going to discuss a bit today. Who's next?
Perfect. So that's it for the introduction. Super exciting, to be working with Kiln. As you guys might know, Kiln is the largest Ethereum's validator by stake. So it's really meaningful, I think, to start working with them as one of our Wave One partners. So to maybe to get everyone up to speed a little bit, for those who are not familiar with Optimum, we're essentially building Web3's memory layer. And what that means is that we're helping build one of the core components of a computer. As you know, computers have memory. And for Web3, which is a decentralized world computer, it also has memory. And it performs a very important function of storing the data, reading and writing from the memory, again, reading and writing data, as well as propagating or sending and receiving data. For our very first product, we're focusing on sending and receiving data or data propagation, which is one of the really big scaling bottleneck for Ethereum, as well as pretty much every other chain. So what we have been testing with Kiln so far is indeed focusing on this aspect with our first product called Optimum P2P, which is a fast propagation protocol. So I would like to maybe invite Sebastian to open up with, why you started to consider Optimum P2P, what really appeals to you, and let's take it from there.
Yeah. So as you probably know, as a staking operator, so we have to operate a lot of validators, and those validators, they have two duties on the network, which directly translate to APY. So one is to attest every 6 minutes on their view of the network, which includes what they think is head of the chain. And the other duty is to once in a while propose a block and propagate it to the network. And so we are interested in Optimum because part of these operations is heavily influenced by the networking. And so any improvement we can do in this area is going to like immediately result in better attestations and better block propagations. And this can be translated to APY. So yeah, I would say that's basically why we are doing this.
Great. APY improvements. Everyone loves to hear that, especially in the crypto space. So starting with Optimum P2P, maybe one of us, let's say Muriel, maybe you can explain a little bit to the audience why Optimum P2P can help kind of improve APY. And then jumping back to Sebastian into what kind of testing have you been conducting and what kind of results have you seen?
Yes, thank you very much. So, Optimum P2P, and we of course have discussed this in some of our previous X Spaces and also on the discussions at the board and with documents. And we basically are doing a reconsideration of propagation, particularly at the consensus layer, where we're allowing to have something which is much more powerful than just currently propagating messages which might end up being duplicated, by replacing those with equations that represent and are equivalent to the original data, but basically avoid any of the issues of duplicates that right now really are important bottleneck in propagation on any chain. So that's what we do. Our name Optimum derives from the fact that actually doing this exchange of equations is optimum. And indeed, on our testnet, and I'd love to hear after this from Sebastian himself, his own experiences and his team's experiences on our testnet. But on our testnet, what we have seen is, multi-X improvements, particularly as the system becomes more contested. So about 2X improvement in latency, but in particular as the system becomes more sluggish, the gap between what we can achieve and the current solutions without coding can achieve just grows, and it grows non-linearly, and it grows very dramatically. Of course, I'll leave it to Sebastien to explain better what that means for their business.
Yeah. So basically, what at a high level, what we are doing is like we set up like beacons. So that's like consensus nodes, the ones that are responsible of broadcasting messages on the Ethereum network. We set them at different places in the world where we know there is validation power around. And then we tweak a bit those beacons so that they receive blocks and attestations, not only via the Ethereum Gossip network, which is like the current way of doing it on Ethereum, but also via Optimum. So those beacons are a bit special in a way because they have two channels from which they can receive data and also two channels through which they can send data. So whenever a beacon receives a new block from Optimum, then it's going to spread it to its neighbors via the Ethereum Gossip. And because they are like geographically located near validation power, our goal is to improve that way the propagation time of the block through the entire network. So on our side, this approach does not change the overall mechanism of our validation. We just add a side channel that performs better. And yeah, that's basically the idea. For now, we are still fiddling with like custom sidecars. That is like software that does the plumbing for it to work well. So we don't have like a good like concrete results to share, but soon we should be able to have some. So right now our focus is mostly on the Hudi network, but once we have some results, we'll go with mainnet on this.
Yeah, very exciting. Integrating, with Hudi testnet, get some test results on the performance gain and the APY gain, and stabilize it, before moving on to mainnet is the way we think about delivering it, stage by stage. As we think about, rolling this out, what are the different steps of testing that you are kind of envisioning for Kiln to test, and how will this impact the overall performance?
So those.
Sebastian, I think you are not unmuted
Oh, yeah,
on.
sorry about this. I unmuted the wrong side. Yeah, so I was saying that for validators, as I mentioned before, they are doing two things. They are proposing blocks and producing attestations. And so those are two things we are like used to measure at scale. And so there are two metrics we are really interested in, and those are the metrics we plan to qualify in different stages. So the first one is like when you vote on attestation, like when a validator votes every 6 minutes, it has to vote on three things, like a source target, a source epoch, a target epoch, and a head. And those three components of a vote are going to be matched to a reward. So if you get those three right, those three votes right, you are going to get the maximum reward. And if you get one of them off, you are going to get a small penalty. And the one that is mostly influenced by the network is the head vote. And this is because, so basically a head vote is like your validator tells the network what is the latest view it has on the network. So if, I don't know, the current proposer is propagating a block and is a bit slow and it arrives a bit late to your validator, there are chances that your validator won't see it in time and is going to vote on the previous block on the network, which means it's going to lose about 1/8 of the attestation maximal reward. So there is a direct translation to APY. So one way to qualify optimum here is to just look at the percentage of attestations that have the correct head. So right now on Ethereum globally, I think it's something like maybe 97 or 96% of the networks that gets the head vote right. So it's quite like a substantial amount of votes we can likely improve that way. And the second signal we are interested in is the propagation time of blocks. And so in this case, the story is a bit different. So as you create a block, you have to propagate it in time. And if like a majority of the network didn't see it in time, then your block is going to be missed, marked as missed or orphaned. And in that way, you will lose the entire reward of the block. So there, the signal is quite simpler. It's like the percentage of blocks we can land on the network. So to recap, two signals we're interested in: the head target accuracy and the percentage of blocks we propose. Does that make sense?
Great. Yep. No, this is super helpful. I think most of people, most of our listeners, probably know about staking into validators, help you earn rewards, but really seldom think about where do those rewards actually come from and what are the sources. I think it's very helpful that you help break it down, into different sources of income, different sources of APY, and thereby connecting the dots why by improving part of the underlying mechanism how you get these rewards will help improve the eventual APY. So let me turn it to Harpreet to discuss a little bit on what are some of the um, important topics in the propagation that we're handling, and how does that translate into some of the revenue sources that Sebastian was commenting?
Yeah. So I think in CL layer there are so many topics which are going on, but not all the topics are critical from the reward perspective. There are some like pick and block and attestation. These play the important role when it's about considering that how much reward gain or APY gain can be there. So usually what happened here especially in the fork or the peak load time, what happened, the cost our existing gossips of mess struggle to forward messages, fast enough across the network. It really struggle. Usually what happened here, the message follow peer-to-peer hops and can get delayed due to many reasons, like can be a back pressure, poor peer scoring, or there may be a mess disconnect somehow. But we can handle it better. At Optimum, what we recently experimenting it and what we find out that we forward this time critical message like beacon block and attestation using coded propagation. So instead of one large message, the data is broken into a shards, encoded and delivered in a parallel. Even if some shards are lost or delayed, doesn't matter. The validator can still reconstruct the original message quickly. And this reduces the worst case delivery latency and ensure that validator can process the block early enough and attest in the slot which they are assigned to. And it improved the inclusion distance and overall the APY.
Okay, very interesting. Sebastian, do you have anything to add or comment on that?
No, that's it.
Sweet. So going from here, I think it would be very interesting, to discuss, one thing, which is, I think many people are probably very curious, how did Kiln become the largest Ethereum validator by stake, right? I think there must be a lot of things that you guys are doing right, and a lot of attempts to get continuously improve and continuously get better. So from a improving APY perspective, there must be a lot of things that many people care about. What are some of the current attempts that you have made to improve that? I think you haven't unmuted.
Sorry, I keep pressing zero. Most of the APY this area is first like getting to a high attestation rate with time. So like this is more like let's say a classic operator job where you make sure that your architecture is redundant, so that if there is, I don't know, like a machine that goes off or something like this, you are able to quickly automatically have the validation key fall back to another beacon or to another node, so that the downtime is very limited. But I think on this side, it's quite like it took some time maybe for like the landscape to become very professional on this. But I think these days there is not much difference on this side between operators. So then the next thing was around timing games. So this came from the realization that strangely, like 2 or 3 years ago, if you were operating validation keys in South America, for instance, you were getting a higher APYs than the rest of the network, just because you were basically receiving transactions a bit later than the rest of the world and propagating them a bit slower. And so there is this counterintuitive thing that if you delay up to the maximum the block proposal, you are going to accumulate more transactions in your block, and your block is going to be more valuable. So that's another way of increasing APY. These days, so most operators are doing it, even if you are like just using MEV-Boost, you are probably doing it without knowing it because relayers are doing it on your behalf. But this is one area where there is still like a small edge maybe to get, but it's quite, yeah, I think most of the network is aligned on this right now. But yeah, that's one way we got to it.
That's very interesting. I think timing game in order to improve the APY, particularly when you're proposing the block, is one of the area that we look deeply into. Maybe Muriel, you can comment on that and share some of our thoughts.
Yeah, absolutely. So I mean, and I think there the issue of being able to capture more information in the same amount of time is really important, right? That's basically what these timing games are. And so it doesn't always necessarily mean that just because you're getting effectively a better throughput, that you will go ahead and do, finish everything faster. It just means that you're actually able to capture more, know about more transactions, and that directly impacts what your advantage is relative to others. And I love the example that Sébastien was offering about what was happening in South America, that somehow you're going last. How could it be that you're doing better? But instead of going last, you could just say, well, I actually just managed to get more information in the same amount of time. And that's basically why having lower latency and higher throughput helps you. That's one of the ways in which it helps you. And so it's basically, if you give me 12 seconds, I think we'll talk about that later. If you give me 6 seconds, whatever you give me, if I'm able to gather more information in whatever slot time you gave me, I can never be worse off. And in some cases, I can be significantly better off.
Okay, so getting into the weeds a little bit, as we know, Ethereum currently has 12-second block time. And when it comes to timing game and how that helps improve, APY, Sébastien, can you get into a little bit more detail into how does it roughly work, and why, where are you really making adjustments? What are the constraints you are working with as you play around the timing, and how can lifting those constraints help you get better in this timing game?
Yeah, so one way to look at this is to look at the percentage of blocks you land, because the more you delay, the higher the likelihood you are going to miss the block, because your block is going to be like propagated a bit late, so less actors on the network will see it in time. So right now on Ethereum, so this is probably going to change with the next upgrades, but like right now, so the slot is 12 seconds, and the first 4 seconds are dedicated to the proposer. Like during the first 4 seconds, the proposer has to propagate its block through the network. And so the idea here is like, if you start creating your block at t equals 0 in the slot, and you propagate it immediately, you are going, like, there will be like plenty of time for the block to propagate on the network, and potentially, like, in a way, you miss 1 or 2 seconds of opportunities of potential transactions that could have landed in the block before like propagating it. And so like the TLDR of this is like, there is this cursor where you can decide when you want to release the block to the network, the block that is being built. And you have like to basically know well about your architecture, about the distribution of like slow blocks and so on, to be sure that you are not putting at risk, you are not taking risk and missing blocks without wanting to miss blocks. Like basically what I'm saying is like, this is something that can be controlled and dynamically adjusted depending on what's happening on the network. Like for instance, if there is a lot of activity, it probably translates to higher blocks, higher valuable blocks, but also blocks that are bigger, which means that propagation times are going to be a bit longer. So you probably want to adjust the cursor where it's safe. Yeah, that's basically it.
Yep. Harpreet, do you want to add to that?
Yes, sure. Yeah, that's a very interesting, the time from 0 to 12 second in Ethereum when the complete slot gets executed. And as Sébastien mentioned, that 0 to 4, where the proposer is responsible to receive the best block. And here the PBS plays an important role, where the relay from the block builder, it makes sure that, proposer get the best block, and they try to do most of the MEV simulation and try to find the most profitable block. And here, making the propagation faster on 0 to 4 second, it's something which proposer don't want. Why? Because they wanted to wait as longer as possible to wait for the best profitable block to come from the block builder. And then after that, from the 4-second onwards, when it's ready to expose the beacon block, and he already prepared the block, to the time where 8 seconds where it wanted to propagate the block to everyone and get the attestation done. This is where the main gain comes. And one of the challenge that which we identified and trying to solve, how we can make this propagation faster. And here, as fast the beacon block travels, as early it reaches to all the attestators, we get the attestation done. And hierarchically, we see the gain in reward in the person that was involved, the validators were involved in the attestations, and the beacon block, the creator as well. This is very interesting, and slowly we will see that there are some gain we see from 8 seconds onward. For that, I think Sebastian can explain a little bit more on that, how from the 8 seconds onward, it make more sense to propagate the aggregation of attestation onward.
Yeah, before that, I just wanted to point something out about the six, going down to slot times of 6 seconds, which is very interesting. People went, oh, wow, you can see some real gains. I just want to point out that actually this is what theory predicts we would see. But also theory predicts that this is not a way that is going to have huge benefits, okay? So basically, if you're reducing the slot time to 6 seconds, it's like you're, reducing the service time in traditional queuing. So you by halving, you would expect to have a halving of the time of the delays, but it doesn't scale very much. If you did, suppose that you were to decrease it not by a factor of 2, but suppose that you were to decrease it by a factor of 3, you actually, what you would end up seeing is a 2/9 improvement, and so on and so forth. You can actually predict this with the math. Whereas if you're using Optimum and you're using the code of propagation that we mentioned before, what you're doing there is you're actually improving the service time in a way where you're not mucking around just with basically the granularity. You're actually reducing congestion intrinsically. And by reducing congestion intrinsically, you get these really nonlinear effects that I mentioned earlier in the space. And those nonlinear effects give you, massive gains. So I just wanted to point out that for scaling, tweaking the slot time is fine, but it's only going to tweak the delay. To really get a substantive, massive difference in scaling, you need to actually improve the throughput, and that's what we do. But wanted to hand it over to Sebastian.
Yeah, thanks. So yeah, I'm not sure. Like, we wanted to discuss about what's happening after 8 seconds currently in the slot, right? But basically, so the first 4 seconds are for proposers to broadcast or block. After that, attesters, they see the block coming in, and they basically have to make a choice on what they will vote. So this is where they decide the source, the target, and the head. And so they send their attestations, and those are aggregated, so that basically to reduce the number of messages on the gossip network. And once they are aggregated, basically the rest of the network has access to what was voted and can make a choice. So yeah, so today on the network, so there is this dead time of 2 seconds during between 1 and 2 seconds during the first 4 seconds during which you can play timing games. But whatever is around attestations and so on, there is no real point in playing timing games there. But increasing propagation time there is basically going to increase the overall health of the network because blocks will arrive more promptly to all validators, which means they will get better votes, better head votes, which means the network will better finalize. And in a way, it's also a way to scale Ethereum, because if you push Ethereum to the limits, like once you will start like increasing the block size, trying to get more transactions, reducing slot time, as Muriel was mentioning, the constraints are going to increase, which means that the network is going to be more and more important. Yeah.
Yep, that's a great comment. So to synthesize a little bit of what I've been hearing, right? Validators are trying to improve APY by one of the tactics is timing game, by delaying the time when they propose the block. The constraint here that that people are playing with is indeed you want to make sure by delaying it you don't want to miss the block entirely, because if you miss the block entirely and the block doesn't reach the rest of the attester network in time, you're going to miss out all the rewards altogether, not to mention improving it. It's going to be zero for that slot. So you really will have to play between that and find the optimum balance point. And what we are helping here is indeed by one, shortening the amount of time that when you propose a block out as a proposer to reach the rest of the network. So we help you as a validator gain more time, right, to safely play with the timing game. That's how I see this, all come together. I wanna see if that makes sense for Les Sebastian.
Yeah, totally. That's one way of looking at it. Yeah.
Perfect.
So yeah, that's one part of it, and on the attestation side, it elevates the entire health of the network.
Yep. So moving along a little bit, as we think about introducing faster propagation network to validators in Ethereum, what do you see as the potential impact that this will deliver for Kiln, specifically as a validator yourself from a APY, but beyond that to the whole Ethereum ecosystem as a whole? And how you're thinking about beyond one validator adopting it, as more validator adopt it, how that would change, again, the validator individually and Ethereum network as a whole.
So for validators specifically, so all we mentioned about timing games is like it's actually a zero-sum game, which means that if everyone is doing it, there is no advantage, but as long as not everyone is doing it, there is an advantage. So I expect validators to basically have to follow this trend as well. So I mean, like I'm talking mostly about like large node operators and so on. And for the network as a whole, well, because we want to be able to vote in the best way, like vote on the right head. It means like if I take as example like what we've started building with the network of beacons all around the world, which are like connected to Optimum. The idea behind this is to be able to have our nodes, which are currently mostly in Europe, be able to have access faster to blocks that are proposed from the US, for instance. And by doing this, our validators will be able to vote more promptly on the right lane. But by doing this, as our beacons are also like propagating blocks, they potentially get faster than the rest of the network. They will also contribute to make those blocks propagate faster in Europe. So that's how it kind of like brings, like it's a win-win on the attestation side for everyone, I think. And so I expect, yeah, so TLDR, I expect to see some competition catching up on the block proposal side. And on the attestation side, I think it's going to improve the network.
Okay, very interesting. So the first adopters will win in terms of the timing game, because at equilibrium longer term, it's a zero sum. So the first adopters, the early adopters will win more from a timing game perspective. But from a network performance perspective, you're mentioning it's actually a win-win situation where not only the first adopters win, but also the later ones that the ones that have not yet adopted also wins. I think that's a very interesting insight, and maybe I wonder whether Muriel can expand on that.
Yeah, I think Sebastien brings up an excellent point, and I love the way you've framed it, Kent. I mean, basically, it's true that in the end it is a zero-sum game, but it's also true that if you have a system which is more efficient, let's go back to the point that I mentioned before about having repeats. Those repeats are not just slowing things down, they are actually wasting bandwidth. So even if some fraction of validators are wasting less bandwidth in doing the job that they're doing, that actually helps everybody, because that means that you're actually being more efficient with the resources, and you're leading to less congestion, which helps even folks who are not using Optimum P2P. They are actually in a situation where they see a less congested network while the same total amount of useful Ethereum work is happening. So I think it's important to see that it's there is of course a competitive advantage, but it's a competitive advantage where you're not hurting directly your competitors. If anything, you're actually leaving them worse off relative to yourself, but better off relative to where they would have been otherwise, which is a really, really interesting dynamic, I think. And I'd like to maybe see what Harpreet, what his thoughts are on that.
That's correct. I think slowly we have to observe on a different, a small set of integration and observing a little bit on a limited number of group of, the validators who are integrating, and see that how exactly it's impacting. I believe that, the matrix and the data says everything, how exactly it's going to influence the overall integration. But I kind of agree, slowly it's going to improve the overall ecosystem health, where the propagation is required in a much faster way. We'll see the transactions getting added much faster. Yeah, that's how I see the bigger picture.
Great. In order to help our audience understand that, I think one of the analogy that helped me is really about the traffic road road traffic analogy. So you can think of like current traffic in Ethereum is like traffic on the road. When there are many cars, it gets congested. When there are fewer cars, things are moving. Um, what we're hoping to help validators do is effectively helping their cars and the blocks that they are proposing, their transactions that they are receiving and sending out, get to the destination faster. How? By building effectively a highway that flies over it. So there are two benefits here. One, for the validators that are using it, your cars, your traffic are effectively getting to the destination faster. Simultaneously, for the other cars, right, for the other validators who are not yet adopting this highway, but you're staying on the original, road, you're still happier because your original road now is less congested because more of the traffic have left the original road. So it's a net benefit for all. From this perspective, performance wise, it's actually a positive sum game that we're expanding the overall throughput for the entire network. While from a APY perspective, it's very interesting. It's a zero sum game because the overall APY that you can earn is only limited. So the first adopters are going to benefit, and so we want to see how that will end up in the equilibrium where it's incentivizing the first validators to use it while bringing overall benefit to the rest of the network, which is kind of like the ideal scenario we want to see. So moving a little bit along the lines there, I think it'll be very interesting to discuss some of the more recent events. I think Muriel already started touching on one of them, which is one of the Ethereum proposal that we've seen called EIP 7782, discussing about reducing slot time or block time for Ethereum from 12 second to 6 second. I wonder, Sebastian, what do you think about this? What are the potential impact of this? And what are the limitations or other constraints that Ethereum has to move in order to take the full advantage of this?
So like the last days, I was most focused on EPVS, and I didn't have the time to like fully get to the IP. But at a high level, I think it's great to see slot time being reduced so that it improves the UX. That's that's my take. I don't have much more to say about it. I need to read it because last time I was looking at the discussions around scaling. I remember that something like in the first 4 seconds there is like 2/3 of the time that is spent on building the block for like some execution nodes, and 1/3 is on network propagation. So by reducing, I wonder how it's going to fit in 6 seconds. Oh yeah, if you want to take the if you want to be next, Harpreet, if you have something on it. Sorry, I don't have full context on this one.
Yeah. So in my opinion, this reducing time slot to 6 seconds is like cutting slot time in half. Means that you have half the time, half the window to get the beacon block to all validators and collect, timely attestation. So right now, most validators, like barely manage to hit the inclusion in slot at 12 seconds. We already seen a lot of, +2 and +3 attestations. With 6 second slot, if we don't improve propagation infrastructure, we'll see that missed attestation will spike and rewards will drop, and the fork choices stability could degrade it. That exactly, I think, where Optimum comes in. We optimize for sub-second delivery for a beacon block, and most important is the critical duties with beacon. It's become essential for the 6 second slot to taken care by in a correct way. And I think without faster propagation, slot time reduction risk, it's gonna hurt validators earning instead of helping the chain. That will be my take. I think
Yep.
it somehow it should be, yeah, please go on.
Yep. Muriel, do you have anything to add?
Yeah, I mean, I brought up the topic earlier because, as you know, it's one that I find very exciting. I think that, reducing granularity in general in a system, as I said, helps with variance, but it's actually helps in a fairly limited, I wouldn't want to call it marginal, but maybe marginal is the right word. You can sort of do the math and you can see that, the best that you can get is fairly limited. But at the same time, you open a lot of the risks that Sebastian and Harpreet just mentioned, right? So it's also something where you can't keep doing that. You can't just go, say, to 3 seconds, 1 second, so on. You can't sort of just be able to reduce, the slot time and have that carry the day. It's not going to work. It has a limited benefit. It has a benefit, but it's limited. But it brings in a lot of risks and downsides.
Yep. I think that's an interesting, discussion. And, you can always think about kind of think of it as a thought experiment, right? So Ethereum has 12 second slot time, and there's proposal to bring it down to 6 second. Why not 3? Why not 1? Why not just half a second, right? There must be a reason, right? There must be a reason why it is difficult to bring the block time down. And from what we have looked into, indeed, part of the big reason is the bottleneck in networking, because it is really difficult for the whole world of hundreds and thousands of Ethereum validators to sync up with each other in time, and that in time is indeed within this block time. So really connecting a couple points that Harpreet, Muriel, and Sebastian was making, and on that very same note, a lot of people are kind of like thinking about, hey, reducing slot time from 12 to 6. Does that mean we can get more transactions through per unit time per second? And it's actually a different point. So reducing slot time doesn't mean reducing slot time doesn't mean increasing throughput. We know that we've been following Ethereum community, and there is a separate discussion to increasing the gas limit to 45 million gas, and I think that's another interesting place where we think about again, a more powerful networking layer is going to be an important bottleneck to debottleneck if you want to continuously increase the bandwidth or increase the throughput of the chain while reducing the latency. I don't know if Sebastian, you have something to comment on this point or just anything fun to bring up.
Yeah, so one topic I'm quite hyped about is the lean effort from Justin Drake. So the idea is that like in a few years the goal of Ethereum is to scale to 3x every year or something like this. So we should be orders of magnitude with higher transactions per second and so on. And one idea with the lean protocol is to change the way that validation is done. So instead of receiving full blocks on the validator side and having to validate them to then propagate them, instead the idea is to have builders create ZK proofs of blocks. So this implies to prepare the execution layer and the consensus layer to have transition functions that are compatible with ZK and performant and so on. But in this hypothetical future, hypothetical because it's still a lot of research and a lot of speculative things we want to do there. But at the end of the day, the target is to be in a world where the validation can be done on very, very small devices that do not need to have all of the execution side. And what would matter in that world would be to have very low latency, so that the proofs that are generated by builders can be easily validated. So that would be probably small messages that are propagated through the network. And in that scenario, we could expect that networking would be way, way more important. It would basically be the only important thing on the validation side, at least. On the prover side, there would, on the builder side, there will need to be a lot of effort to generate proofs, because generating proofs is very expensive in terms of computations. But in terms of validation, to make sure that those proofs are correct, it would be very, very cheap. So yeah, that's one area where I think networking will become more important in the future. And that's why I also think that projects like Optimum are paving the way for a brighter place.
That's a very interesting point that you bring up. I've been following the ZK side a little bit, from even before I started building Optimum, because before this I was a VC investors and really saw the whole ZK space, starting from nothing into specializing into many different part of the value chain, and you see people start to specialize, improving, generating the proof, etc. And to your point, there are two interesting points. One is how can you make the generation of the ZK proof faster, which is can be very compute intensive. Another one is ZK proofs can be sizable, and you need to now propagate this sizable data object to the network. and then the solving of that or the proving of that is very quickly. But you need to be able to propagate it. And to your point, a networking layer or P2P layer again becomes a very, very important dependent in order to make sure we realize all the benefit here. I want to also hear from Harpreet. What do you think about both this point and the point on the raising gas limit to 45 million?
Yeah, that's a very interesting point about ZK. The ZK has a different fit here that I completely agree with the point that which Sebastian and you guys made. But if we think for the 45 million gas limit, let's think a little bit from the Ethereum point of view and try to understand a little bit technically. So if you see that if we increase the gas limit, that means we are increasing the average block size. So I'm taking into the context of networking layer, how it can affect. That means when we have a bigger block size, we're gonna have bigger payloads and longer execution traces. And that can have a very large state diff, and it can affect the overall block propagations. So in my opinion, that bigger block aren't just on execution layer issue, but they completely slow down the consensus layer propagation too, because it carry a bigger execution payload. And when this block grow, it take longer to verify the gossip, those message across the P2P mesh. And that it will increase the chance that validator don't receive the head, the head of block in the time. And here optimum P2P make more sense because we are split this block into small pieces and can propagate into a parallel in a much faster way. That will be my take. Increasing it like we are increasing and giving a more space, and it's not gonna help the existing networking layer where it already has a lot of problem.
Great points. Moving along a little bit on the current events, I think these days we can't talk about Ethereum without talking about what's happening in New York, in the Wall Street. Lots of ETFs happening, lots of flows into Ethereum. We see Boo Post everywhere. I want to hear a little bit from, maybe Sebastian, your thoughts on the ETH treasury companies, the potentials of, staked ETFs, and how you think about, validators playing a role in the institutional adoption of Ethereum at large, and what it means for the whole space.
So yeah, so this is a bit like strange on the validation side, I would say. There is a sort of transition happening. It's like it started a few years ago, but initially Ethereum, like the consensus layer and so on, was like full of solo stakers, and like there was like a very, let's say, tight community, and like then like came like bigger node operators like us and started like being like having more like a like business units and so on to like try to onboard funds onto staking and so on. And so ETFs is kind of like I would say like the last stage to this evolution. So it's like for our job day to day has evolved a bit in that sense. Like we need to provide more let's say TradFi things to staking, like in terms of reporting, in terms of SLAs, in terms of like due diligence and so on. Like there is way more paperwork, I would say, around it. But like in the long term, so I'm not sure it's going to play, but I think that the actors that initially were very involved, as in like the solo stakers, the spirit is like sadly like fading a bit away when you have like a new ETF coming in with like I don't know, a few percentage of the network. It's probably going to be the dynamics are going to be a bit changed here. So I don't know exactly how it's going to be long term. It's a bit sad, and at the same time, it's also going to bring new use cases on Ethereum. So we win something, we lose something. We'll see how it plays.
Great. So as we wrap up, we are also aware that Ethereum is approaching its 10th anniversary in just 3 days. We've been discussing about how we can unlock Ethereum scaling potential, and I want to invite each of you to share a few final words of hope for Ethereum in the next decade. Maybe Muriel can start, followed by Harpreet, and Sebastian can share the final words.
Yeah, glad to do so. I'm really hoping Ethereum is able to realize the dream of having the world computer, of having a truly decentralized computer. I think that's a very motivating goal, one that everybody can get behind. And I think there's been amazing strides on the side of the compute side. Say, the EVM is just a really very versatile operating system effectively. And I'm hoping that Optimum will be able to provide in there the bus and the memory without which no computer is complete.
Yeah, I can add some point. Yes, I really wanted to see Ethereum add what computer, but I'll add a little bit line that so far Ethereum's first 10 years were about building the engine, but now it's time to run at full speed.
Nice. Sebastian, you want to go next?
Yeah, so what I wish for Ethereum in the long run is to keep the research focus. I think it's one of the rare blockchain where there is a lot of research done before. I really like the spirit around, like the sort of like operational mode of Ethereum with like EIPs and like open research and like communities building things around it and trying to come up with new EIPs and so on. And like, to me, like the community what's leading the chain and not like ETFs coming.
Sweet. So as we round it up, thank you everyone for again coming to our space. A few final words. We will be holding our community call on August 13th on Discord. So if you have not yet joined our Discord, please do so. We will also be at some upcoming events in both Korea Blockchain Week and Token 2049. So if you are around, feel free to send us a ping. And if you have something exciting that you want to do it together with us, also do give us a ping beforehand. And in our very next community call, we'll also have some exciting new additions to the team that we'll be announcing and sharing with the community. In the next couple weeks. So do stay tuned. I want to thank Sebastian and Kiln team again for trusting us and working with us. From very early days. Very glad to have called you partners and look forward to our collaboration going forward.
Yes, thank you so much. Thank you.
Thank you.
All right.
Thank you
Thank you.
everyone
Thanks,
for
everyone.
coming here.
Bye-bye. Thanks, everybody who joined.